Okay, in this video, we're going to be talking about quadratic functions, a quick introduction, defining what a quadratic function is. It's a second degree polynomial. In the general form, it has f of x equals ax squared plus bx plus c. Now we say a, b, and c are just real numbers. A can't be 0 or else we'd lose our x squared term. You can plug in any values you want into these. The domain is going to be all real numbers. All right, the graphs of these, we refer to these as being parabolas. And we're either going to have a highest point or a lowest point on each one of these. We call that the vertex. And one of our big goals in this section is going to be finding the vertex on basically every single one of these. And we're going to use it either to find the formula or it's going to be the answer. Another key feature is the axis of symmetry. Axis of symmetry is just going to be this vertical line that goes right through the middle of our parabola. All right, so if these open up, what happens is they're going to look like this. Could be spread out a little bit more, but they're going to look basically like this. And our lowest point, the vertex, is going to be at the very bottom, meaning we have a minimum. If they open down, they have this kind of look, and that's going to be symmetric on each side. They get a highest point at our vertex. We call that a maximum. So how do we determine if it opens up or opens down? Well, basically what you need to look for is you need to look at a. And how we defined a up at the top was it was the number out in front of the x squared. So if a is positive, it's going to open up. If a is negative, it's going to open down. All right, next up, let's talk about how do we actually find the vertex, because that vertex is going to be a really important point. So we define the vertex to be hk. So for whatever reason, we use these letters hk to designate the vertex. And when we have it in the expanded form, the ax squared plus bx plus c, we have this nice formula to be able to find that vertex. First of all, the x value or h value will be given by negative b over 2a. And then the k value or the y value, we have a different formula, but let's not worry about that formula. Now, how do we remember negative b over 2a? It's a pretty small formula, but how I like to think about it is we've all seen the quadratic formula down here in the bottom right. Negative b plus or minus square root b squared minus 4ac all over 2a. But if we get rid of the part that everyone kind of messes up and forgets, the plus or minus with the square root, if we eliminated that or said the discriminant is equal to 0, what we're left with is negative b over 2a, which you'll notice is the same formula that we're going to use to find our x value. All right, after we find that x value, what we're going to do is take the x value, that's going to be a number, and plug it back into the function to get our y value that goes with it. All right, so that's why you don't really need to worry about a second formula to find k. All right, the standard form for a vertex is a multiplied by the quantity x minus h quantity squared plus k. So this can be a little bit difficult to remember. How I like to think these through is I like to think about this as being transformations and moving our function around, moving that vertex around to get it located in the correct place. So if we've moved it left or right, we attach a number directly to x inside the parentheses. That one's kind of counterintuitive to how we think it should move. And then if it moves up or down, our y value would change. We attach a number at the end to the entire function, and it's going to move up or down. That gets attached in the fashion we would expect it to. All right, our book uses standard form to refer to this version. Vertex form is utilized in other books to mean the exact same thing, and it may come up on your homework as vertex form. The last thing to talk about is the axis of symmetry. Now, the axis of symmetry, if you can refer to our graph up here at the top right, is this vertical line that cuts right through the middle of the parabola. All right, so since it goes through the very middle, it goes right through the vertex because the vertex is always in the middle. And it's going to be symmetric about this axis, meaning that the left-hand side and the right-hand side are going to look the exact same on either side, just a mirror image of one another. So how we get that is it's going to be a vertical line. So all the x values on that line are going to be the exact same. And it cuts right through our vertex. So we're just going to use whatever the x value is for our vertex and say all these x values on this line have to be that same x value as what's on our vertex. All right, good quick introduction. We're going to be using this to work some problems in a minute. All right, good luck.